talk is held by Mr. Florian Degen. Florian is Division Director at the Fraunhofer FFB, and he will now introduce the concept of Fraunhofer FFB. And I'm quite interested to hear it.
Perfect. So thank you very much. Thanks, Thomas, for a kind introduction. I would like to give you a glimpse of an overview how the innovation process, the process of technologies from lab to industrial scale works with us. I couldn't unfortunately see the presentations before, but usually a presentation in the context of battery cells starts with a graph like that. The market is rising. You see that it's basically coming from zero and the entire market is skyrocketing. So suddenly there was no market, and then there's a huge mega market in the future, and somehow we need to address that. And that was a reason why the Fraunhofer FFB was founded. I'm sure Professor Tübke mentioned parts or almost everything of that already before, but for the people who joined us later, or maybe you forgot, this is a brief overview about the Fraunhofer FFB. We are an open battery cell factory for research and development purposes. That means everybody who wants to can access our machinery, similar like UK BIC. For that we got 700 million euros initial funding. We are more than 150 employees, and just for an estimation, our entire lines, we have several lines, we are able to produce 7 gigawatt hours per year on the electrode side if we run 24/7 and if we run without scrap and 100% overall equipment effectiveness. Just to give you an idea how large that is. And well, what's the problem with innovation and technology? You probably all know the TRL level, technological readiness level, and this is probably also well known. You have lots of funding in the field of fundamental research and things like that, and but then there is this so-called valley of death, where you need to put or invest a lot of money to, well, then commercialize a technology. And well, the Asian companies are here. They have their factories, they have their knowledge, and well, European companies are somewhat here in the beginning, maybe even a bit further, but there was a long time in the beginning when the FFB was founded. Shall we enter the battery cell market or shall we not? And then the German government said, okay, we need to decrease the risk. And what are you doing when you want to decrease risk? Well, that's the idea behind that. So in Germany and Europe, we have lots of good machine tool builders and equipment manufacturer, but you can't test the machines when you don't have access to a factory. And that's why the government said, okay, Fraunhofer FFB shall cover this risk by providing infrastructure on different scales, like a small-sized line, medium-sized line, and industrial-sized line, where European companies can obtain knowledge and try new technologies, because you don't stop your gigafactory just to try like 10 days if your new idea of dry coating works. You need to do it somewhere else, and this means massive infrastructure investment. Only a couple of companies can do that, like BMW or Volkswagen, to name the big ones, but a mid-size equipment manufacturer, they just can't. And that's why we're here for. And well, of course, the goal is to accelerate, to speed up, to catch up, or at least to be also competitive. So how does that work with technology? Well, when you're from university, or usually sometimes also Fraunhofer, there's the technology push. We have like 30,000 research fellows and engineers and chemists who are also kind of inventors, who do everyday research and invent new technologies. This is a technology push. But on the other hand, you have also the market pull. And as you see, technology push and market pull doesn't meet always appropriately. That means that scientists sometimes don't even exactly know what is the demand on the market, and the market sometimes doesn't know what's possible or available on the technology push side. And that's why so that's what I just said, technology push and market pull do not always meet efficiently. That's why we're here for. Basically, that's the idea of Fraunhofer, but here in the battery part, Fraunhofer FFB in particular, we shall be the mediator. And that's also our value proposition. As mentioned before, our product are not battery cells. We are not producing battery cells and sell them. Our product is innovations and know-how for efficient and sustainable battery cell production. But to be innovative, of course, you need to manufacture battery cells. Otherwise, it's just desk research. So that is our value proposition. And to make that in an appropriate way, we do following. We switch our position. We say if we really want to make a benefit for Europe, we need to change our perspective and take over the perspective of an industrial manufacturer, like a battery cell manufacturer, and just see what is there or what are their daily problems. And then look from this perspective on the available technologies. What is this in particular? So there are basically 4 different main criteria, which are for production of battery cells important. The cost, time, and quality, most production engineers know, but what's new, I mean, it was there before as well, but it's becoming even more important in future, and in this time, it's sustainability. And what are this buzzword, what's there behind? Costs, for instance, are typically capital expenditure. Quality are scrap rates. Time is production output. How fast can you produce? Sustainability is energy consumption, but also what kind of energy do you use? Do you use natural gas? Do you use electricity? Do you use hydrogen? And so on. And following this thought, we developed by ourselves, we call it heat map of pains. This, I know, sounds a bit dramatic, but I think this is a good, acronym for what we are doing here. We split time, cost, sustainability, and quality into different aspects, and then analyze where does it really hurt. If we produce battery cells, where is the pain? Where's the pain in terms of output, in terms of cost, in terms of energy consumption, in terms of scrap rates? And then you see here are some, green fields where you say, okay, we can do research there, but problems are somewhere else. And that are all the really red spots here. And in the next step, we analyze, okay, what are ways of becoming better here? And then we call it technology studies. I am going to show one technology study later, but just to show the process, how we identify then solutions. For instance, here, new stacking technologies or new end-of-line testing technologies, new formation strategies address this red field. Technology study here in this red field, dry coating technologies, but also alternative drying technologies like infrared, near-infrared drying, laser drying, and so on. And just to show you how our innovation process works, I brought the case studies, so to say, of dry coating. So what did we do here in terms of dry coating? Basically, let's say like a venture capitalist, we screen the market. So we screen the market by research projects, literature, patents, but also interview what are available technologies out there, not just which we know, but everywhere on the world. And then we go in a rough analysis and then into a detailed analysis. And this we did with dry coating. What you see here is a portfolio of different dry coating technologies, because there is not just one dry coating. we identified here 15 different dry coating approaches. On the X scale, you see the technology readiness level till 6, and then here on the Y axis, the cumulative rating. So what's the potential of a technology? And you here see the different spots where we think what's high potential and benchmarks. Here on the right side, it's basically the same, just written in a tab form. Where is our technologies better, same, or worse? And fun fact, by the way, this study now is 2 years old, and there was a Tesla battery day, and this year's Tesla. And 2 years ago, we rated Tesla with a technology readiness level of 6, although Mr. Musk said it's coming soon. Now it's 2 years further. There is no dry coating working with Tesla. And 30 minutes ago, I just saw an article in a newspaper that Tesla mentioned today or yesterday that dry coating, which was aimed for in the Gigafactory in Berlin for beginning next year, will be at least 1 year coming 1 year later. So we're talking Tesla announced dry coating now in 1.5 years, basically. Status quo. So I would say our estimation here with technology readiness level 6 was quite good. Although 2 years ago, everybody said why Tesla brings dry coating technology next year. So this was our estimation and our underestimation, because Tesla, well, it's they have their own technology roadmap. Our bet is on direct calendaring, a technology where we assume that it has more potential but is less developed. And then we do so this is just a minor fact sheet how this technology direct calendaring works. The company, it's also luckily for us, another Fraunhofer Institute, it's called DryTrack. They built a very first prototype, which you can see here. And then we make fact sheets like you see here with advantage, disadvantage, who are the key players, what's the technology readiness level, and so on. And we said by ourselves, we will invest in this technology. So from the 700 millions, which I mentioned before, we have a certain amount of money for high-risk projects like a venture capitalist in technologies like that. And we said we invest 4 or 5 million euros for the next 3 years to build a next-gen prototype machine together with Fraunhofer EVS and accelerate that and scale that up in our factory in the FFB fab. And this was just for dry coating, but we're not doing that with dry coating. We have lots of so-called high-risk projects. We call it innovation modules, where we're seeking to reach industrial scale with. This is once the extrusion with the goal to reduce or increase the content and reduce solvent amount. We have a dry coating, which started beginning this year. We have also laser cutting technologies like laser slitting, improved formation strategies, and what's coming very soon is a continuous single sheet stacking process, near infrared drying, and we have a long list of possible next technologies like pre-lithiation, fast electrolyte filling, lithium metal processing for post-lithium ion batteries, different kind of quality analyzers like X-ray CT analyzers, mini environments and smart dry rooms, but also innovations in the calendaring process. And what's important, we would like to define that together with you, with our customers, with our partners, with our research partners, because we don't do the invention of new technologies by ourselves. We work as an accelerator with infrastructure, with resources, human resources, know-how, but also the possibility to access together public funding, for instance. And you're more than welcome to go into discussion here with us to see if next innovation module maybe can be with technology of your choice. So like that, we want to become the European hub for battery cell production research and know-how and innovation. And which is really important is we don't see ourselves as German project. We see ourselves as European project. Although, of course, when it comes from Germany, I think it is very important that our understanding is really we are European and a European project, but also, of course, a global project. But here we are in a European in a way, and you are very welcome with us to work together. Thank you very much. And of course, thank you for the BMBF for the funding. If you have any questions, these are our partners, and here are my contact details. You're welcome to add me on LinkedIn, and feel free for questions. Thank you very much.
Thank you, Florian, for your quite interesting talk. During your talk, there was one question within the chat. The question was, as we move to mass production, what is the projected reject rate or scrap rate on quality, and what to do with the scrap and the reject? Are there any, let's say, ideas, technological topics, technology studies within the FFB about how to handle scrap?
Thank you very much. I mean, what's the aim for scrap rate? That's of course 0. That's the aim. I don't know where we will end up. Target is minimum. And I think it's very difficult to answer that generically, but we all know in battery production at the moment in ramp up there is scrap rate, and there will be scrap rate in a notable amount also in the next years. So you are right, we have to deal with that. And basically there are 2 ways how we address that. What I did not mention is that a very similar project like FFB, a bit smaller, exists also in the area of Münster where we are located, which addresses also the topic of recycling. So a large recycling center should be constructed close to the FFB. There is the political negotiation at the moment and first studies how that should work. But of course, this is the big picture, but also on an operative scale or level. We are working on, we call it internal recycling. So we have partners, and I didn't mention it here, but we have also studies where we check how can internal recycling work. What does that mean, internal recycling? That means basically when you have electrode foil, which is coated and dried and calendared, which did not yet touch electrolyte. How can you recycle that and bring that in your factory back to the beginning? It doesn't need to go to another location. So yes, we address that. We also have very first research projects which we proposed for, and this is a very big topic where we are looking in, because there will be, we believe there will be a scrap rate even in 10 years, because production technology improves, cell technology improves. So we don't see a continuous phase where everything is stationary. And if you improve your technology, there will always be scrap rates on you, and you need to deal with that.
Thank you very much for your answer. During your last answer, there was another question in the chat. You mentioned X-ray/computer tomography for innovation around analysis. Do you have partners, or do you searching for partners for such topics?
So we are always looking for partners in IP. We don't have a premium partner we're working with. We are looking what's best, and usually there is not the best technology. There's always a technology which is more suitable for case A, and another technology which is more suitable for case B. And yes, we are in touch with some partners which do CT in the X-ray, but we are not limited to those. Actually, we're looking also for other partners which are willing to work with us. So you're very welcome to get in touch with us.
Thank you very much. Now there are no further questions anymore, but I have one question. During your talk, I got the impression that the concept of UK Big and the concept of Fraunhofer FFB are quite similar. Where do you see the biggest differences and similarities between the two facilities?
That's a good question. I don't see if Ahmad is still here in this round, but
He's not.
okay. But even though, yes, it is very similar, but there is also differences. I would say what one difference is the scale. We have three lines. We have a small size line, a medium size line, and a large scale line. And the line of UK Big, the original one at least, that was the size of our medium line. So we have a line which is, or are going to have a line which is larger and a line which is smaller. But I think the most important difference is that at UK Big, with us, we are a Fraunhofer Institute, and we have, or going to have, like 100 people which do really science in the field of battery production and battery cell production. There we have another perspective, and we also have the access to the entire Fraunhofer society with 30,000 people and to other universities. So I think this is a very big difference, which UK Big does not have. If you look in terms of just the infrastructure, I would say UK Big is probably very similar, yes. But how we are organized and how we work with the technology push side, I think there we are different.
Okay, thank you very much. I guess now we are quite good in time. We have now a short break to 11:15, and we will meet back with the next speaker, which is Ms. Saskia Wessel, at 11:15.